Good day, sir. We are Group 2 and we will perform laboratory activity number 7, which is the forward kinematics. For the objectives, this experiment will enable the student to perform forward kinematics with the aid of MATLAB and to simulate the robots based on the given joint space with the aid of MATLAB.
So the first procedure will be computing for the value of x, y, and z of the articulated robot with the following values below. The figure in that is shown is the figure that is shown is will be using that. So we will be having a three set of groups. The first group will be having an angle of 30 degrees, 70 degrees, and 80 degrees. The second group will be having an angle of negative 50 degrees, 120 degrees, and 150 degrees. So the last group will be having an angle of 130 degrees, 45 degrees, and 120 degrees. Uh, so second procedure po, sa baba Patrick. So the second procedure is setting the link and angle based on the value stated a while ago. So for the third procedure is using link command and plotting the appearance using plot command method. So baba po ulit. So here is the output plot of the first set of the group. The following set of group will be seen later. So for the fourth procedure is applying forward kinematics, finding the location of the end effector using fkind command. And lastly, we'll be tabulating all of the data that we simulated and computed.
And and now we proceed for the comparing of two results of computed value and simulated value. First, we will present the computation of the computed value by using the given groups of theta, theta 1 of 30 degrees, theta 2 of 70, theta 3 is 80. And in using a solution, given solution that we know how to get a angle. And first angle that we get is 7.9 degrees at x. And for the next is the y angle, we get a 7.79. And lastly, for the say angle, we get a 4.56 degrees. And next, we will proceed to the simulated value. And first, we set up the simulation. And for the angle of x, we get a value of 6.277. And for the y is 3.624. And the last one is z angle, we get a 2.638 degrees. And the next one is for the b, we will present the computed value. For the computed value, we use a given group of data, theta 1 of negative 50, theta 2 of 120, and theta 3 of 150. And using a formula that we know how to get the angle. And for the first angle, x, we get a value of negative 2.06 degrees. And for the y angle, we get a 11.56. And the last one, for the same angle, we get a 2.46 degrees. And next, we will proceed to the simulation to know the simulated value by putting the given group of group of data. First is negative 50, the next one is 120, and the last one is 150. And for the simulation, we get the value of x is negative 1.928. For the y angle, we get a 2.298, and the last one is for the c angle, we get a 11.2 degrees. And the last letter is for c, using a group of theta theta 1, 130, theta 2 of 45, theta 3 of 120. And using a formula that we know to get the value of angle of that we need. For the x angle, we get a negative 7.28. The next one is for y angle, we get a 3.97. And lastly, for the C angle, we get a 8.67 degrees. And next, we will proceed to the simulation to know the simulated value. And that's all. Angle of 120, angle of 45 degrees. And lastly is for or for theta 3, we use a 120 degrees. And now we will know the given needed value of angle. For the x angle, we use up we we get a value of negative 6.452. For the y angle, we get a we get a 7.69 for the y angle. And lastly, for the z angle, we get a 2.69 degrees. And that's all for the comparing of the result of computed and simulated value for the forward kinematics activity 7. Thank you po. Putol ako.